students, welcome back to day 30 of 99% in 99 days. So today we are going to revise the chapter metals and non-metals, where I'll be talking about the chemical properties, the physical properties and the extraction process of metals. Okay, so please watch this complete video, make notes from it and revise it daily to get 99% in 99 days for your 10th boards. Okay, so let us start now. First of all, there are two parts, I can say. Like, first part we'll be talking about physical and chemical properties. In the second part, occurrence of metals and corrosion. Okay, so in metals we have here, what do you mean by metals basically? So metals have the tendency to donate electrons, means they can lose electrons. Okay, then they are very good conductors of electricity, they are electropositive in nature. And in metals what happens, okay, they are electropositive in nature. And in metals, in the valence shell, okay, in the outermost shell, you will find 1, 2 or 3 electrons. Okay, coming to non-metals, they have the tendency to donate, they have the here I want to change, they have the tendency to accept electrons. Okay, non-metals can accept electrons and they cannot conduct electricity. They are electronegative in nature. Electronegative means capability or capacity to attract pair of electrons. Okay, next, in the valence shell there are 5, 6 and 7 electrons, right? So that they can gain 3 electrons, they can gain 2 electrons, then they can gain 1 electron to complete their octet. Okay, fine. Now coming to the physical properties of metals. So generally conduction, we know metals are good conductors, non-metals are bad conductors of electricity. But there is an exception here. Graphite is a very good conductor of electricity, even though it is a non-metal. Next, coming to ductility. So what is ductility? Ductility is means converting to thin wires. Okay, and there is metals are ductile and non-metals are non-ductile. Malleability means converting to thin sheets. Okay, converting to sheets means you can hit the metal and can convert it into thin sheets. Okay, so here again metals are malleable, non-metals are non-malleable. Now coming to luster. Luster means a shiny appearance. Okay, so metals are generally lustrous, non-metals are dull, they are not lustrous. But here also we have an exception, that is iodine, which is a non-metal but is a lustrous element. Okay, next coming to sonority. Sonority means when you hit a metal, okay, or when you hit a substance, you can find or you can hear a ringing sound. Okay, that is called as sonority. So metals are sonorous and non-metals are non-sonorous. Now density, metals have high density, non-metals have low density. Physical state, generally metals are solid, generally. Okay, but here also we have an exception. Mercury is a non-metal but it is liquid, mercury is a metal but it is liquid in the state. Okay, coming to hardness, generally metals are very hard. Okay, and non-metals can be found in solid, liquid, gas, all the 3 states. Okay, now hardness, metals are generally hard, but here we have an exception. Lithium, sodium and potassium, they are very soft metals. You can easily cut them with a knife. Okay, you do not need you do not need any sharp object, it can be easier, so soft. Okay, but on the other hand, hardness, generally non-metals are soft, but again here is an exception, diamond. Okay, diamond is a non-metal or an allotrope of carbon, but it is also very hardest substance found on the earth's surface. Next, coming to melting and boiling point. So generally metals have high melting point and boiling point. Okay, but here we have an exception about gallium and cesium. Okay, these are soft metals. These metals have very low melting point and boiling point. And then coming to diamond. Diamond is your it is a non-metal but it has also high melting point or boiling point. Okay, clear. Next, coming to chemical properties of metals and non-metals. So we have valence electron. Valence electrons of metals are like 1, 2, 3. On the last electrons it is 1, 2 and 3, and in non-metals it is 5, 6 and 7. Okay, their electron metals are electron donors, non-metals are electron acceptors. This we have already discussed. Metals are electropositive and non-metals are electronegative in nature. Now generally the oxides, means metals when react with oxygen they form metal oxides, and these metal oxides are basic in nature, and the oxides of non-metal are acidic in nature. Then metals are corrosive, non-metals are generally non-corrosive, and metals can, like, because they lose electron, right, so they will form cation, and because they gain electron they will form anion. Okay, now reducing and oxidizing. Now see, so when you are if they are donating electrons, right, metals are donating electrons, means they are undergoing oxidation, and when they are undergoing oxidation they will behave as reducing agent. Okay, and in case of non-metals they are accepting electrons. Now accepting electrons means they are undergoing reduction, and they will behave as oxidizing agent. Okay, clear? Now let us see some reactions of metals and non-metals. So the first one is reaction with oxygen, then we'll see reaction with water, then reaction with acids, reaction with solution of other metals. Okay, coming to reactions with oxygen, so metals react with oxygen to give you metal oxide. Now metals combine with oxygen to form basic oxides. Example, we have 2Cu plus O2 gives 2CuO. Okay, next aluminium oxide and zinc oxide, these are basic plus acidic oxides, means they have both the properties of basic and acidic oxides, and such oxides are called as amphoteric oxides. Okay, so you can see aluminium oxide reacting with HCl, aluminium oxide reacting with sodium hydroxide. Okay, so we have AlCl3 plus water, and we have Na8AlO2 plus water. Next, non-metal form oxides which are either acidic or neutral. Okay, so C plus O2 is giving you CO2. This is a non-metal oxide, and this, if you dissolve in water, will give you an acid or will form an acid, so it is an acidic solution. Okay, next, coming to about reactions with oxygen only, some more thing. Sodium and potassium react very vigorously with the oxygen. Okay, so that is why sodium and potassium are stored in kerosene, so that they can't catch fire. Okay, next, at ordinary temperature the surfaces of metals such as magnesium, aluminium, zinc and lead, okay, they are covered with a thin layer of oxide. Now the protective oxide layer prevents the metal from further oxidation. Okay, next, iron does not burn on heating, but iron fillings burn vigorously when sprinkled in the flame of the burner. Okay, next, copper does not burn, but the hot metal is coated with a black colored layer of copper oxide. Okay, so copper does not burn in the presence, so what happens, the hot metal is coated with a black colored layer of copper oxide. Okay, next we have silver and gold, they do not react with oxygen even at high temperatures. Okay, fine. Next, coming to reactions of metals with water. So metals react with water to give you metal oxide, and these metal oxides react with water to give you metal hydroxide. Okay, so you can see one example, the elements which reacts with cold water, we have sodium and potassium. Okay, so NaOH and KOH plus H2. Then those which react with hot water, you have calcium and magnesium, so you have calcium hydroxide and magnesium hydroxide. Then with steam we have zinc, iron and aluminium. Okay, so that is ZNO, Fe3O4 and Al2O3. Okay, and we have lead, copper, silver and gold, these do not react with the water. Clear? This is very important table, you should remember here. Next we have reactions of metals with dilute acids. Okay, so metal react with dilute acid to give you salt plus hydrogen. Okay, so you can see, like for example, hydrogen gas is not evolved when a metal reacts with nitric acid. Okay, this is very important. Now if you take this acid as a nitric acid, okay, then there will be no reaction between metal and nitric acid. Now what is the reason for that? Because nitric acid is a very good oxidizing agent. So whatever H2 is produced, that H2 is oxidized to water. Okay, so HNO3 is a strong oxidizing agent. It oxidizes H2 produced to water and itself get reduced to any of the nitrogen oxides like N2O, NO or NO2. Okay. Next, magnesium Mg and manganese Mn react with very dilute HNO3 to evolve H2 gas. The order of the reactions of metal can be like this: magnesium, aluminium, zinc and iron. Okay. Next, what is there is something called as aquaresia. So it is a mixture of 3:1 concentrated HCl plus concentrated HNO3. Okay. So HCl is 3 parts, 1 part is concentrated HNO3. This mixture is called as aquaresia. Okay. Next we have, you can see here the reaction with acids. So for potassium it is very violent, with sodium also it is very violent, calcium very rapid, you can see magnesium it forms hydrogen bubbles, with zinc it is slow, with iron it is slow, with hydrogen there is no reaction, with copper also no reaction. Okay. Next we will see reaction with a solution of other metal. So here we know that displacement reaction. So this is, see, this is a salt, this is a solution of a metal B and there is a metal A. So if A is more reactive than B, then A can displace B, okay, and we will get AC plus B. Clear? Okay. Next, coming to the reactivity of metals. So this is the order we have: potassium, sodium, calcium, magnesium, aluminium, zinc, iron, lead, hydrogen, copper, mercury, silver and gold. Okay, fine. So reactivity order is in this way. So that means potassium can displace all these elements, sodium can displace from calcium to gold, calcium can displace magnesium, aluminium can displace zinc, like that. Okay. Fine. Next, reactions of metals with non-metals. Okay, so when a metal and a non-metal forms, we get an ionic compound. Okay, so for example, there are some properties of ionic compound. So physical nature, the ionic compounds are generally solid. Okay, and coming to melting point and boiling point, they have very high melting point and boiling point. The solubility are generally they are soluble in water and insoluble in solvents such as kerosene, petrol, etc. Now, conduction of electricity. The conductors of electricity through a solution involves the movement of charged particles. Okay, so that means this ionic compounds contains ions. So when they are in molten state, okay, when they are in molten state, that is why the ionic compounds, when they are in molten state, they can conduct electricity. Okay, so if this ionic compound is in the solid state, okay, then they do not conduct electricity. Okay. Next is very important about occurrence of metals. So generally metallurgy, what do you mean by metallurgy? It is the branch of science and technology concerned with the properties of metals and their products and purification. So minerals and ores, very important thing, you should know the difference between them. The elements or compounds which occur naturally in the earth crust are called as minerals. Okay, but those minerals which contains a very high percentage of a particular metal and the metal can be profitably extracted from it are called as ores. Now let me take an example for here. Suppose you have a mineral A, okay, and here you have mineral B. Okay, in mineral A you have metals like this, and in mineral B you have metals like this. Okay, so now if you see from here, if you take, suppose to remove this mineral you need 50,000 rupees, and for this one also you need 50,000 rupees. But here you see you will get only this much amount of metal, whereas in this you can get this much amount of metal, right? So this is more profitable. So this mineral can be called as an ore. Okay, clear? Next, coming to gangue particles, the impurities present in the ores in the form of sand, soil and dust etc. is called as this impurities is present in the form of sand, soil and dust. These impurities are called as gangue particles. Okay. Now what is the meaning of concentration of ore? So from this particular ore, when you remove all the impurities and only minerals are present, this is called as an ore. Okay, clear? This is called as enrichment of ore. When you remove all the impurities and just keep the metal in the form, that is called as enrichment of ore. Now what happens, because metals are very highly reactive, okay, so they are not found in their native state. Okay, they are found in the either in the form of oxides, sulfides or carbonates. Okay, so you need to purify them, you need to remove all the things and we need pure metal. So we need some procedure for that. So here are the steps involved in the extraction of metal from the ores. So first we have concentrated the ore, we have removed all the impurities. Then there are three categories. One is metals of high reactivity, metals of moderate reactivity and metals of low reactivity. So for high reactivity metals, like for example potassium, sodium, calcium, okay, magnesium, these all are high reactive metals. To get their pure form, you need to do electrolysis of the molten ore. Means their ore is melted or like converted it into liquid form, and then it is enriched with the ore, and then we do electrolysis. Okay, and next coming to for the low moderate reactivity, means zinc, iron, Pb and copper. Okay, so for them what happens, these moderate reactivity metals are either in the form of carbonates or in the form of sulfides. Okay, so carbonate ores by calcination, means what is calcination we will be discussing, but by calcination they are converted to oxide. Similarly, sulfide ores by roasting are converted to oxides. Okay, now these oxides are reduced to metal and then they are purified. Clear? So first of all, you need to find that the metal is of which category, high reactivity, moderate reactivity or low reactivity. If it is a high reactivity metal, then it is converted to the pure form is obtained by electrolysis. Okay, now moderate reactivity metals, they have like two parts. They can be either in the form of calcium carbonates or in the form of sulfides. So the carbonate ores, okay, are converted to oxides by a process called as calcination, means where you burn the ore in the absence of oxygen. Now the sulfide ores are converted to oxides by the process of roasting, means where you burn the ores in the presence of oxygen. Okay, now once we get these oxides, these are reduced to metals. Now after reduction we get purification of metal. Okay, and then we have low reactivity metals. Okay, these low reactivity metals, that is they are either sulfide ores, they are done with roasting, then we get metal and then we refine it. So we will understand this in detail. So for low reactivity, okay, the oxides of these metals can be reduced to metals by heating alone. Okay, so because the oxides, if you heat them, you will get the metal by itself. So for example, first we had sulfides, we converted it into oxide by heating with presence of oxygen. This process is your roasting. Okay, so we got oxides. Now these oxides are heated to get pure metal and oxygen out of it. Okay, so HGS is called as what? It is a ore of mercury and we call it cinnabar. Okay, next example is of copper. So first, copper is found in the form of sulfide. It is reacted in presence of oxygen to get copper oxide. This process is also roasting. Now copper oxide, you just treat with copper sulfide, again you will get pure copper and SO2. Okay, fine. Next, for the metals with medium reactivity. Okay, so which metals are there in this category? Iron, zinc, lead and copper. Okay, so now they are found either in the carbonates or in the form of sulfide. So carbonates are converted to oxides by calcination, means by heating in absence of O2. Okay. Next, sulfides are converted to oxides by roasting. So what is this one? Sulfides will be converted to oxides by roasting, that is by in presence of O2. Okay. Example, ZnS plus 3O2. Okay, if you see here, what we will get, ZnO plus SO2. Okay, so this process is roasting, means you are converting the sulfide ores to oxide in the presence of oxygen. Now once we got this ZnO, or okay, this is your roasting process. Here you see, if it is present in the form of carbonates, okay, then directly we heat in the absence of oxygen to get zinc oxide and carbon dioxide, and this process is calcination. Now once we get ZnO, the oxide, then it is reduced with carbon to give you Zn plus carbon monoxide, and this is a pure metal. Okay. Next you can see, for example, MnO2. Okay, so it is not that always carbon will be used for reduction, you can use even aluminium for reduction. So MnO2 plus Al, this will give you Mn plus Al2O3. Similarly, Fe2O3 plus Al will give you Fe plus Al2O3. Okay, clear? Fine. Next we are getting with high reactivity. So I told you, for high reactivity metals, what is the process? Electrolysis. Okay, so here the carbon cannot be reduced, carbon cannot reduce the oxides of sodium, magnesium, calcium or aluminum, which are high reactivity metals, right, to the respective metals, because these metals have more affinity towards the oxygen than carbon. So how we obtain them? We obtain them by electrolytic reduction. The metals are deposited at the cathode, the negatively charged electrode, whereas the chlorine is liberated at the anode. Okay, so you can see one example here. We have this one. Suppose I took copper chloride solution. Okay, so for example, if I have copper chloride, okay, so here it is, and 1 second. Okay, so now what will happen? In this you have Cu2 plus and Cl minus, right? So Cu2 plus will move towards the cathode. Okay, it will move towards the cathode, and Cl minus will move towards the anode. Okay, and it will get deposited here, and we will get pure one. Okay, so this is anode and this is your cathode. Okay, fine. No, sorry, that is correct. 1 second. Okay, the signs are actually given wrong here, otherwise this diagram is correct. I will just change the sign here. So this one will be negative and this one will be positive. Okay, so copper 2 plus positively charged ions will be attracted towards the negatively rod charged electrode, and it will get deposited there. Okay, next coming to corrosion. So what is corrosion? I think all of you know that. Deterioration of a metal when they react with substance like water or air is known as corrosion. It causes damage and disintegration of the metal. Here there are 3 different types of corrosion. So Fe reacts with O2 and H2, give you red color substance, that we call it as rust. Now copper reacts with carbon dioxide and water to give you copper carbonate, which is green in color. Next, silver reacts with S to give you silver sulfide, which is black in color. Okay. Next, how can we prevent them? So by painting, oiling, greasing. Then you can do chrome plating, where you cover the surface of the metal with chromium. Anodizing or alloying is a very good method of improving the properties of a metal. Corrosion can also be reduced. Okay. Next, coming to alloy formation. So what is an alloy? Alloy is a mixture of more than one metal. Okay, so here we have some example. Iron, nickel and chromium is called as stainless steel. Brass is called as copper and zinc. Bronze is called as copper and tin. Solder is an example of lead and tin, and amalgam is an example of mercury and metal. Okay, so these are the alloys name, these are the corresponding elements name. Okay, Okay, so students, here I want to introduce to you about something called as DSAT, okay, Diksha Scholastic Aptitude Test. So now after 10th, we are like generally students are very confused about your career, like which career path you should choose. So for this we have launched this DSAT, where you will be getting a 60-minute lecture, and then you will be giving an aptitude test, and then you will be having a one-on-one mentorship where you will be told like what is your strength and weakness, and based on that you can choose your career, right? So definitely it will be a best tool you should that use to make a wise decision for your career. So make sure, if you want to join this, please register. The link is there in the description section, so please go there, register for this and attain the DSAT and choose the best option for you. Okay, fine. So that's all in this, students. So we have revised the metals and non-metals. In tomorrow's class we are going to do a lots of questions, so please do not forget to subscribe, and see you soon in the next class.